Okay, so we're going to go ahead and get started with PDH class number 4, Trey Wilder with LG. We're going to talk about A2L refrigerants and VRF. So this is our final session of the day. Trey is the senior product support engineer at LG Electronics USA. And as discussed, he's going to talk about A2L refrigerants and VRF and what VRF is doing to address that, which is, we get a lot of questions on that, so that's good. So live attendees can download the PDH certificate below. Don't forget about that. For those watching this on YouTube or the podcast on a future date, please check the video or show notes, the descriptions, and you'll see my email in there. To shoot me an email, and I'll send it back over to you. I'll send you the PDH. So Trey's expertise in VRF systems and his in-depth knowledge for A2L refrigerants are sure to provide valuable takeaways. I do a lot of presentations, Trey, on A2Ls, and I am not, I get tons of questions about VRF, and I know a little bit from some of the LG presentations I sat through. So, but I know there's a lot of questions out there, so I'm looking forward to this presentation. So take it away. If we get some questions, do you mind if I throw them at you during the presentation? Is that okay?
Not at all. If I don't know the answer, I'll go find the answer. So bring it on.
All right. Well, you take it away, sir. I'm looking forward to it.
All right. Thanks, Tony. And thanks everyone for being here today. Sticking out until this last session here. Hopefully my monotonous droning tone doesn't put everyone to sleep. So here we go.
Well, they've been
My name is
listening to
Trey.
me all day, so I'm no better. So
Yeah, we're about a tie, I guess. Yeah, senior product support engineer at LG. And just a little bit about me. I've got a degree in mechanical engineering. Started out with a TXV EEV manufacturer in Dallas and held several positions there in quality procurement and engineering. And then for the last 17 years, I've worked for a couple of VRF manufacturers in product development and also applications engineering roles like I am doing now. So, what I want to do first is kind of go back and talk about how we got here. Um, so, to cover some of the background on it, the Montreal Protocol was done in 1987, and it was created to phase down your HCFCs, of course, because they deplete the ozone layer. HFCs do not deplete the ozone layer, but some of those do have high GWP potential numbers. Now that we have reached the zero ODP target, we're shifting the focus towards the GWP numbers. So the Kakali Amendment of 2016 was ratified by the Senate in 2022, and then it was signed by the president in October of 2022. And this was all created to phase down the HFCs that do have the high GWP value. This was aimed to reduce the total consumption and production of HFCs by 85% by the year 2047. So the way this is going to be achieved is through transitions to these lower GWP refrigerants and also reclamation of HFCs across multiple industries, and not only refrigeration, but also includes aerosols, insulation and foam blowing, and things like that. So this brings us to the AIM Act, and the AIM Act came out in 2020, and it started us down this path to achieving the Kigali phase down. But prior to ratification, this enables the EPA to administer the HFC phase down on a schedule, again, targeting an 85% reduction by 2036, which actually exceeds the Kigali target. So this facilitates the transition to the next generation technologies through sector-based restrictions. So we're going to maximize reclamation and then minimize releases from HVAC equipment.
there you go.
So this was the slide on the Montreal Protocol and the Kigali Agreement that I talked about. And here you see how we've released we've lowered the ODP down to zero, and we're now going to concentrate on this GWP number here. So let's see. I think you heard all of that.
Mm-hmm.
And then this was the phase down. This is
Phase
I think what
down
we left
slide. Yep.
off. Yeah. So this was the AIM Act I talked about, which gets us down the path of lowering the GWP potential refrigerants. So this is a production and consumption phase down. So don't mistake this for a changing refrigerants or reducing levels or anything like that. So that's what this is showing you here.
That's the production of the actual refrigerant itself.
It's the production and consumption, yeah,
Ah.
of it, yeah. It's kind of a funny graph, but
Mm-hmm.
it's what we've got. Now, I've got some questions thrown in here in different places. So this was the first one that I had here. And the question we get a lot is, will these new refrigerants be forced to phase out in 2029? And the answer is, for now, no. There's no regulatory activity towards developing lower GWP limits. So we don't think anything's going to change for about 10 years at least.
Mm-hmm.
And it's good to note that in Europe, they've got a restriction on PFAS use, but one of the components of our 454B is a PFAS chemical. So it's still being used, and we figure it's going to be around for quite a while.
Mm-hmm.
And here's another question here. This has to do with VRF, but there's a lot of confusion on the transition dates for products. So the year extension for VRF is extended, and they've now set the transition deadline for VRF systems at January 1st of 2026. So here you'll see this chart here shows what your CARB and EPA requirement dates are for different types of equipment. So chillers being January of this year, ACs including mini splits, chillers was January 2025. And then for VRF, as I mentioned, it's the transition deadline is going to be January of 2026. So this brings us to some of the EPA technology transitions that they are publishing. So this confirmed this rule that was done in October last year. It confirmed these new system phase out dates of the higher GWP refrigerants and new equipment. And it also defined the production dates where products could no longer be used for new systems. For us, we compare the import date to these phase out dates since our stuff is manufactured elsewhere. So as I mentioned before, it's going to be 1/1/25 for ACs. This does include VSMS, which is the variable speed mini splits. And again, January 1st for VRF in 2026. They
Kevin,
did
could
not,
you? Oh, I'm
yeah,
sorry. I get this question all the time. Why is
yeah.
VRF a separate date than the rest of the equipment? My answer is because it's more complex and it was harder to change the refrigerant, but I don't know. That's what I tell people. That's my guess. But is there reason behind that or?
Well, this next slide may actually explain some of that.
Okay.
Um, so to finish this one up here, they didn't mention anything about service. They didn't address that, but components, whether that be whole indoor units, outdoor units, heat recovery units, whatever, they can be used for service after these new equipment phase out dates. Um,
Mhm.
they can also be produced for service after the phase out dates, and we're allowed a 3-year sell through period for complete systems. Split systems, of course, are not complete systems, but rather are sold as components that are then assembled out in the field.
So
And
for
then
those watching who don't know what sell-through is, can you expand on that?
that just means that we're allowed to continue to sell products for an additional 3 years after that.
After the manufacturing cutoff
Right,
of 1/1/26. So if you've
right.
got a warehouse in Texas or whatever, and there's a bunch of LG or whoever's equipment's in there that's
Hmm.
VRF, you have 3 years after 1/1/26 to sell it.
Yeah, to get rid of your
Got it.
inventory or whatever. Now, you were mentioning why VRF is different. Part of it is that they're still trying to figure some of the things out for VRF. I
Right.
guess is the best explanation. So there's an interim final rule that was done in December, and the rulemaking for this was kept real narrow. And oh no, that's the final rule. Let's see, the interim final rule. Yeah, this rulemaking was kept real narrow and focused so that we could address the most pressing problem, which was the sell through of the products affected on 1/1/25. So the limit of this rulemaking was kept tight to ensure we could quickly resolve this issue. So it addressed the sell through, but only for split systems that are less than 65,000 BTUs.
Mm-hmm.
And the components themselves, well, this allowed for installation for 1 year past that new equipment phase out date to be completed prior to January 1st. Components can still be manufactured, and it allows installations to be completed up until 1/1/26. And again, they did not address service for this.
Got it.
So there's also a proposed rule that we're looking at now, and this has the same language as what was in the December 26th interim rule on the previous slide. And this proposes a 1 year period to get VRF systems greater than 65,000 MBH installed after the production import phase out dates for new equipment. So components manufactured before 1/1/26 would be able to be installed prior to 1/1/27. So this is a proposed rule, and we were hoping that they would have a final rule by the end of the year, which is now, but we haven't seen anything yet. So this is probably why it's taking longer for us, is because some of the stuff has got to be defined specifically for VRF.
Mm.
So hopefully that answers that question. Now, if we look at these new A2L refrigerants, some people have chosen R32, some are going with 454B. And as this chart shows, it's kind of hard to see. You don't need to read it, but there's different advantages of using one versus the other in different applications. We chose R32 for our systems because it provides the greatest benefit to those systems using that refrigerant. And then to add to it, R32 is chlorine free and it has a lower GWP fluorocarbon with an ODP of 0. So that's good for it.
Mm-hmm.
R32s does fit in with the GWP limit of 700, coming in here at 675. And as everyone knows, since it's classified as an A2L refrigerant, it of course is eventually flammable, but it's considered very manageable. It's got a very low burning velocity, very low heat of combustion, and a really high auto ignition temperature. So
Mm-hmm.
for us, we think that it's a good choice. And if you remember, R32 is half of the component of 410. So
Mm-hmm.
it's not like this is something completely strange.
Yeah, in
We're
my
getting Mhm.
research, it's hard to light, it's hard to keep lit.
Very hard. Yeah.
If you look on, we're not condoning this as a scientific experiment, but there's a lot of videos where people are trying to, don't try this at home, but it is very hard to light. I had the vision of this being like propane when it first came out, but it's
We
nothing
all do.
like that at all in terms of you can't, it's really hard to light it. Now that's not to take away of the seriousness of, taking
Sure.
this refrigerant and putting it in a 410A machine. We talked about that in the last session. Like you cannot do that. You will, I mean, you can, but you'll
Oh,
violate
yeah.
a bunch of laws. You could lose your business. It's a major, major deal because the equipment UL rating is different. So I try to downplay the flammability in terms of the dangerousness of it, but then I try to make sure everybody understands like it's not a drop in for 410A. It is a different machine. It's different
Mhm.
UL. It's right. Is all that correct?
Yeah. Yeah. It cannot be a drop in for the other. That's true.
Yeah.
It's got some differences, but yeah, even being flammable, we see this as a positive in a lot of ways.
Hmm.
So, that's one little minor thing in the whole grand scheme, I think.
Mm-hmm.
We're going to use the same PVE oil that we do now. Um, so there's not much different there. I do have another slide, but I didn't include it here that talks about the burning velocities and the combustion rates of all that for R32. But it basically just proves what we already know and what you just said, that it's
Mm-hmm.
very hard to ignite and keep lit. So here's one of the differences between these two refrigerants. R32 does have higher discharge temperatures, and so for some people that may be a problem, but um, for us, it's really not.
Mm-hmm.
We've got, with our controls and inverter technology, we can manage these slightly higher temperatures without any problem. In doing that, that means we can take advantage of all these other benefits of R32, where other technologies may actually be a little challenged. So
It
that's
seems like all the VRF manufacturers are, I know you don't work for all of them, but like it seems like
yeah.
they all are going to 32.
Yeah, well, one of them makes it, so that kind of
Right.
makes sense for them.
It's a no-brainer for them, right? Yeah.
Right. But yeah, I think everyone's doing this. I do want to say that we will have a few pieces of equipment that are R454B.
Okay.
I don't think that's any of the VRF stuff though.
Got it.
So that brings us to this little chart here, which
Mm.
is available on AHRI's website. So
Yeah, if you're watching on our website now, if you're watching the live stream, there is a link to this site in the chat. Just scroll up in the chat. If you're watching us in the future, just type in like AHR A2L building code map or something, it'll pop up.
good deal. So AHRI identified that our industry was pretty far behind in the area of code readiness.
Mm-hmm.
So they actually went and hired some lobbyists to create and develop some legislation and regulation in each of these states to, kind of help pave the way for the updated codes, which, commonly take sometimes different cycles to get adopted all the way down to the local level. And it can take quite a bit of time. This map is actually kind of outdated, but it just gives you an idea of the building code status progression. And you can see the legend there to the right.
Mm-hmm.
States in light blue show that the code legislation is signed into law, and then ones with green indicate that updates are made to the regulations and codes. State legislative or regulatory paths, of course, establish dates after which outdated codes will be superseded by these current codes. So the idea behind this was to help ensure that these codes would be much more quickly adopted than the typical process, which can take years sometimes. And then it also just leaves the industry caught between codes that are being ready and the regulations taking effect. So they're trying to speed up this process. And as I mentioned, this is an interactive map that's on the HRI website. It's so you can look and see what's going on in your area and elsewhere.
Good stuff.
Uh, Another question is we're going to be starting to talk about leak detection. And one of the questions we got early on is, so you're going to need a refrigerant sensor on every braze joint, and then do systems greater than 60 ounces need sensors. So per code, if you do your proper brazing techniques and do what you're supposed to do, then a braze joints are considered just part of a one continuous pipe. So
Hmm.
no, you do not need sensors everywhere. And neither of the standards, ASHRAE or UL, require a system to have a sensor for all applications. So that is that.
That's good to know.
Yeah,
HVAC is already complicated enough. We don't need any more sensors.
no kidding. Well, we're going to have a few. We're going to add a few, but there's good reasons why.
The
So,
fewer the better, right? Yeah.
yeah. So looking at how these designs are going to be affected, they did some updates to ASHRAE 15 and also to UL.
Mm-hmm.
And so they added some new details and safety measures that enable the safe use of these new refrigerants. To remind everyone, ASHRAE Standard 15 is a application safety code standard, while the UL 60335 is an equipment or product safety standard. So think about the tag on your hair dryer that says, "Don't use this in the bathtub."
Mm-hmm.
That would be an equipment product safety thing.
So the UL is what you all as manufacturers have to adhere to in terms of the construction of the equipment and compliance. And that's one of the major
Mhm.
things with the A2Ls, is it's a different UL requirement. That's why you
Right,
can't put, we already talked about that earlier, but that's why it's a different machine because of
right.
the A2L requires a different UL rating.
Mhm.
Yeah.
Yeah, they're not just two different versions of the same thing. There's differences behind them.
Right. Cause we get asked all the time if an owner has an older piece of equipment, can I just take all the refrigerant out and clean it up and change a few components, put this in? And I'm like, no, that it
Uh,
violates the UL and you don't want to do
yeah,
that. So,
please don't.
yeah.
So these updates to ASHRAE 15 2022 include some major changes to the room volume and your RCL or refrigerant charge limit calculations. It also introduces these new concepts of release mitigation controls and another concept of releasable charge. And I'm going to get into more detail about all of these. And they also clarified some of the things around connected spaces. And here I've got the sections of the code if anyone wanted to go and look these up. But this is where they're all in the code in these
Hmm.
different sections. So I mentioned RCL, refrigerant charge limit. In the previous versions of ASHRAE, meaning 2019, the max charge was simply your RCL times your room volume. With 2022, we've added some new calculations here, and this helps manage these new refrigerant applications. So here in this example, without air circulation, the maximum charge for well, let's see. Yeah, without it, the maximum charge for a room is calculated as the refrigerant charge that's in this table times your occupancy limit, which I guess is just a factor. That's how you get that number there. Occupancy factors are 0.5 for institutional and
Hmm.
one for everything else. And so in this example here, 24 and a half pounds of refrigerant is allowed for a space with 5,600 cubic feet of volume. So that would be a 700 square foot room with an 8-foot ceiling. So 25 pounds. And for comparison, one of our 2-ton split systems with like 90 feet of pipe and a couple of cassettes is about 8 pounds of refrigerant. So,
Oh, so the max is way over that.
right. Hmm.
And the max the system can have that would potentially leak into that space.
Correct.
Am I saying that correctly?
Yeah.
Yeah.
Now, if you do have air circulation, um, and that can be continuous or initiated by refrigerant detection sensors or
Hmm.
whatever, your max charge then is the LFL times zero point 0.5 times the room volume. So for that same size, same volume of room, you can have 53 and a half pounds of refrigerant. So
Okay.
this shows you how with these concepts of circulation and things, it actually gives you a lot more flexibility than we had before.
Excuse my dumbness. Why would you not have air circulation? I'm confused. Does this mean in the mitigation strategy or
I'll get into that too.
okay,
It's
gotcha.
all related, yeah. And it is kind of
Okay,
a
gotcha.
strange thing to wrap your head around
Because I'm
since these are
thinking, well,
all
of course you're gonna have air circulation. if you got air conditioner and you could put it on the fan on, you would always have air circulation. But okay, gotcha.
Yeah, right. There's different ways to look at that. So one of the things I mentioned was this concept of release mitigation controls. So the minimum room volume and the maximum allowable charge requirements that exist, that's how we had it set up in the old standard. So the
Mm-hmm.
updated standard gives us much more safety options and tools. So like I said, it gives you a lot more flexibility when you're doing your designs. So just for an example here, release mitigation controls can be used to limit that possible refrigerant charge that could be released into that particular space or zone. So what these controls include are integrated refrigerant leak sensors,
Mm-hmm.
leak detectors, and I'll talk some more about that, but they're going to be included in all of the indoor units. It also is going to include these shutoff valves that you see, where it's labeled valve box. And then when this particular mitigation system is used, the possible quantity that could be leaked into the room is limited to the volume of refrigerant that passes through the valve during detection and closing of the valves, plus whatever charge you've got downstream. So that is what you have to deal with rather than the entire charge of the whole
Uh,
system.
so
So
it's
this gives you,
minimal,
uh-huh, because you can shut this refrigerant
right?
pipe off and isolate everything here. So that's kind of how we're going about it.
That's good.
Yeah. So additionally, we've got controls that can trigger other mitigation actions like air circulation, ventilation, opening zone dampers in the ductwork, if you have any things like that. And then that moves us to this concept of releasable charge. So with release mitigation controls, ASHRAE introduced this concept, and the variable for it is MREL, as you see here. Basically, M release is the variable. So in this example, you can see that without these mitigation controls, this variable is 100 pounds. So that's the entire charge of the whole system.
Mm-hmm.
And then with these mitigation controls, that charge is reduced down to about 3 pounds.
Wow,
And
huge
this is
difference.
a huge difference. Yeah. So this is assuming that it takes about 30 seconds to detect the leak and about 15 seconds to then close the valves.
So 100 pounds. What? Oh, that's the concentration limit. That's okay. Got it. Got it.
Yeah.
Okay. So
That would be
that's
like
the
a
max.
two frame system. Looks like we got 100 feet of pipe out to these HRUs and then more piping beyond that. So decent sized system, I guess. But yeah, this difference is huge in those two numbers.
Trey, we had a question here. Let's
Mhm.
see here. Somebody is asking. Oh, we have Batman's here. Batman's in the chat. So I wonder if it's the real Batman. I don't know, but they're asking. So if you were in an apartment high rise with VRF and the piping went through a closet, you'd maxed out the non-ventilation pounds question mark. Does that make sense?
Um, I don't know exactly. Yeah, there is a lot of talk about pipes and shafts and things like that
Mm-hmm.
and what that means. We were doing all this before, putting pipes and
Right.
shafts. So a lot of that doesn't really change, but
I mean, this
um,
is easier to meet than before because we didn't have we had to concern ourselves with the entire charge. Like I'm thinking this is actually easier
yeah, it is. It
because we
gives you a
didn't
lot
have the
more
close
options.
off valves and the mitigation strategy. And if you had a 40-ton VRF system and you had a bunch
Mhm.
of small rooms, it was almost impossible to do that. You'd have to chop it up into smaller VRF systems to meet that. But
Yeah, you were
gotcha.
stuck. You had no
Yeah,
option but to deal with that value. So yeah, this
got it.
like I mentioned, gives you a lot more options, a lot more flexibility. Now,
As terms of there was another question here about leak detection. Maybe you're going to get into this, and you could tell me that's fine. But
mm,
like, do you need a sensor in every room, or where are the sensors? Or I think you have a slide on that, don't you?
yeah, I'll get into that,
Okay.
and I'll jump ahead and say no, you do not need these controls on every single room or zone. You only use this where you need to, so
Got it.
even more flexibility. So looking at these sensors and valves, all of our indoor units, except for just a couple of the single splits, will have sensors built into them standard from the factory. And they're connected to the PCB, and everything's all in there contained. Shut-off valves, we're going to have those available as a one-to-one valve kit. We're also going to add the valves to our heat recovery units. And what the heat recovery units do is basically allow us to heat and cool a building simultaneously, because you run 3 pipes into them and then you've got 2 pipes coming out to your indoor units. So if you've got a heat recovery system, we're going to have these valves built into these units. And I think we're also going to have the HRUs available without the valves, where you could save a little money if you don't need them in certain
Hmm.
areas. And then we're not just going to have these one-to-one single port shut-off valve kits. We're going to have 3 and 4 port boxes also. And those will just be piped like heat recovery units, but you'll just use 2 pipes all the way through instead of 3.
Hmm.
So yeah, all of our stuff is going to have a sensor built in, and we're going to offer these shut-off valve kits ourselves as an accessory. Um, so getting into the sensor logic, this is an example of our system, and we're gonna have 4 different error codes actually. So you've got one code for when you have a refrigerant leak, but then we had to get another code in case there was just a fault or a problem with the sensor itself. And then these sensors are good for 10 years, but 6 months before its end of life, you're going to get a different code to tell you that time is running out. And then on the last day of its life, it will throw a different code to tell you you're done. You need to go replace me. So
Hmm.
the way our system works is you're going to sense a possible leak at the indoor unit. That will then send a signal to all the shut-off valves to close. Your compressor shuts off, and I believe you then initiate the indoor unit fan on high speed to help to dilute uh, any refrigerant concentration in the room. And I want to mention that all of this is required uh, per the UL standard. So we had to do this basically. Looking at connected spaces, with ASHRAE 15 2022, they added quite a bit of clarity around connected spaces with locations and calculations for sizing your natural ventilation openings. And it now offers a path to utilize mechanical ventilation with a separate equation here to calculate your ventilation airflow. Um, Mechanical ventilation for this does not necessarily have to be outside air. It could be air from another connected space. Um, and then the mechanical ventilation could either be continuous or just activated by the refrigerant sensor, either way. So in this example here, we've got what is this, a 700 square foot room that has a system charge of 28 pounds. So this tells you that you could have an opening that needs to be about 0.55 square feet below 1 foot above the floor, which is kind of hard to wrap your brain around, but that
Hmm.
wording is. And if you do this, then you can count the neighboring space as part of your room volume. So again, more clarity, more choices, more flexibility.
That's good. Here's another question from Jonathan, or a question from Jonathan Suture. Are are the indoor units required by UL to be on an emergency power if they're shutting off valves on detection of a leak? I don't think so, but what do you think about that?
No, and I think our valves are actually going to be powered closed.
Mm.
And so I said, well, what happens in the event of a power failure? And they mentioned that there'll be some kind of a switching mode power supply in these.
Mm-hmm.
And I haven't done enough research yet to know exactly how that works, but maybe they store enough energy to send a fast 5-volt DC signal once they lose power. I don't know.
Right. And just so
It's
everybody knows too, like everyone's still got a lot of questions on a lot of this stuff from a
yeah.
manufacturing standpoint because we were talking about this in the previous PDH session. Like this is a major deal. Like it's a huge pain, you
Hmm.
know? And so somebody asked about getting a copy of the slides, and really the manufacturers don't want to share the slides because everything's changing. They don't want to be liable for something that gets out there and in a week it's wrong. I'd say contact your local rep and they'll get you the most current information. That would be my best
Yeah.
suggestion on that because there are a lot of equations in here, and it's tough sometimes to see that online. But you can get a lot of this information from your local rep that's up to date.
Right.
So
And not to spoil it, but we've got some things in place where you're not going to have to worry about any of this, which I'll get to.
okay,
We're going to have software that's going to calculate a lot of this stuff for you. So
nice.
now moving to standard 15.2, standard 15 is the commercial side and 15.2 is the residential side. So 15.2 and UL were updated with some new details and safety measures, just like standard 15, to support the safe use of these refrigerants. So 15.2 is an application safety code. And again, the UL code is the equipment or product safety standard. So, yeah, they've included a lot of major changes here to the refrigerant charge limit calculations. They've added some safety measures and introduced that concept of releasable charge on that side as well. So looking at this RCL limit for 15.2, here's another example here. It's showing that without ventilation, your maximum charge for a room is calculated as the refrigerant charge from the table times your refrigerant conversion factor times your air circulation factor. So refrigerant conversion factor for R32 is 1. That's your C variable. And again, don't try to think too hard about this stuff because we've made it to where you don't need to worry about it too much. Air circulation factor is 2 for systems with air circulation and 1 for others. So in this example, roughly 7 pounds of refrigerant is allowed for a 200 square foot space without air circulation. And if you have air circulation, you can have up to 13.8 pounds. So big
Hmm.
difference there. And when there is ventilation, the equation is the same, but there is a refrigerant mass variable that's added in here. And again, this ventilation can be mechanical or it can be continuous or triggered by your refrigerant leak detection or whatnot. And then looking at maximum charge for 15.2. In 15.2, there are charge levels for mitigation. And the variables for these are M1 and M2. And I guess for R32, M1 is 4.1 and M2 is 35.1. So what these numbers do is tells you that if your system charge is below M1, then it can be applied as is without any requirements. So if it's below 1, then you're already in compliance. So if you're between M1 and M2, then the system must be compared with the maximum allowable charge, and it may require mitigation controls. If you're above the M2 charge level, then the charge is unacceptable for residential applications. You'll have to figure something else out. Here's an example of a residential system. And again, you'll see here that this is just showing how we would do the same detection system using the shutoff valves and the sensors, and then initiating ventilation from there. 24, let's see.
So the detectors, is there one in each room, it looks like, is that right?
Yeah,
For a home?
these will be built into the indoor units themselves.
Oh, they're built into the indoor, so you don't have to worry. Oh, got it. Nice.
Yeah, LG actually has a refrigerant leak sensor available globally, but we've never brought it over here. And I think this is better that it's all built in anyway, and you've got one less thing hanging out on the wall or connected somewhere. So safety measures, and then releasable charge again for 15.2. There's different levels, whether you're in heating mode or cooling or off. And what you do is you use the highest value basically in your calculations. So if you utilize safety measures, now your releasable charge is compared with the maximum allowable charge instead of the total system charge. So let's
Well,
see
that's good
here.
news.
Yeah. So
I think
in this,
initially a lot of folks I talked with were like, this is never going to work because of the new requirements. But yeah,
yeah, right. No, it's going to work. It's going to work just fine. So in this example, we've got one of our multi-systems, still residential, but it's got several different indoor units connected to it. And these safety valves are going to be built in, like I mentioned. This is a little different. We call it a branch distribution or BD box, but it'll have a shutoff valve in it as well. So in this particular system here, without the valves, the total system charge is about 14 pounds, 13.6. And then with the valves, the releasable charge for this particular unit is 2 pounds. So as I mentioned, these MREL values, the largest number is used in the calculations. So in this table, it shows the equations used for R32. And I guess it's good to note that it's a little tighter and more complicated for 454B. So your MREL for 454 will always be larger than R32 for the same size system. Now, this is a new concept that's been released in the fourth edition of the UL standard, and it's called ETRS or Enhanced Tightness Refrigerating System. And this is a designation that says that this particular system is a system that has indoor units that are made to a higher level of confidence that large refrigerant leaks will not occur in normal and abnormal operation. So with this ETRS designation, you can utilize releasable charge with safety measures, including these valves, and also incorporate airflow, like we've talked about. So when you look at our nameplates, they're actually going to have an ETRS designation on the nameplate that signifies that this is what this equipment is designed for.
got it.
Here's another question, which I kind of alluded to earlier. Are there any tools or software being developed to help with design and compliance? And we actually have some interim software until we can get our final versions of stuff done. So we've got something called R Checker, which is a refrigerant compliance tool, an online tool. We have a preliminary version of our system selection software that includes R32 systems. And we did this so people can start laying out jobs and working on projects that they know are going to be R32 in the future, even though we don't have all the equipment specs built into the software. So this will still, let you lay out a system and move forward in the meantime. And then we're going to have our regular design software with calculators built in to do all of this stuff for you. So looking at R Checker, this is a web-based calculator that helps you be compliant. It's currently set up per the fourth edition of UL, but we're working on versions that are for ASHRAE and also the 3rd edition of the standard. So what our checker does, it gives you a place to put inputs in for your release mitigation controls, inputs for your connected spaces, and then you get outputs for charge limits and safety measures, which is kind of nice.
That's nice. So
So
you
it
have to
looks
sit
like,
around and do all these calculations all day, is what you're saying.
exactly right. Yeah, that's no fun for anybody.
I know design engineers have a lot of time on their hands. They're just sitting around, so they don't mind doing that
Right.
by hand.
Yeah, trying
That's
to
a
make
that's a
every
joke for all you listening. I know you're extremely busy and you got enough on your plate, and
yeah.
worried about
Hopefully
new
there's
refrigerants is that high on the list, I'm sure.
right. So yeah, the first half of this is to tell you what's going on, and the second half is to tell you don't worry about it. So
I love it.
I got to do one to do the other, you know. So
Yeah, I hear you.
first you'll input system information here, including your equipment installation height, your total system refrigerant amount. If you're using release mitigation controls, like shut-off valves and ventilation, you can choose those here as well. When refrigerant leak detection system is checked on this or selected, our checker will then ask you to input some more detailed information about the detection system.
Mhm.
So, yeah, if you didn't, I guess, is this where you choose? No, I don't think it is. But yeah, it's going to ask you some things. A lot of this input here is actually used later to calculate
Got it.
the leakable charge or your MREL releasable charge. And then looking at connected spaces, you have another option for your mitigation controls being the ventilation. And they can be indoor to indoor, indoor to outdoor, current, there's several ways you can do it. If you're ventilating to a neighboring indoor unit space, you'll then input the area and the height of that zone. Um, and then for mechanical ventilation, you also need to input your airflow rate, CFM here. So these are all the input sides of our checker. And then what you get out of it is a results page that looks like this. So when ventilation is selected as one of your mitigation controls, the releasable charge is actually the system charge, since in this particular example, there's no shutoff valve used. So your total area is calculated by adding the current room and the connected room together for ventilation. And since this total area is larger than the minimum required total area, this installation is possible. So our checker will also calculate the maximum allowable charge for your space. So you'll get this little graph that pops up with green and red areas on it. And the little red dot there in the middle is actually where your particular system sits in all of this. So the red dot is where it falls within ventilation, and the total area above this is the total area is above the minimum, and you can see that this system is good. So as long as you're in this area, then you're good to go. So this will tell you where you're at. And then you're also going to get some outputs for safety measures. So the results page will give you some detailed information about all these different safety measures. There are more requirements in UL than just checking for minimum room volume. So if you want to learn more about the details of this stuff, our checker will give you some more information on the calculations and things. However, for complete details, the complete standard's got to be referenced. So our checker is not going to guarantee compliance because it's just a tool. It can't. So you still got to be aware that you've got to be in compliance with the full code. Now, these are all temporary interim solutions until we can get all of this stuff built into our what we call LATS, is our design software.
And I'm
So
sure, like, in general terms, just because we're in the PDH setting, this is probably something most VRF folks are going to be doing, right?
They've all got their
They've
own
all got to
system
basically because it's
selection
too
software.
complicated to
Right.
expect anybody to do that on their own. So
Yeah, you can do it by hand long way, but no, it's much easier with the tools that we've
yeah,
gotten
forget
developed.
that. Yeah,
Yeah, right. So we're going to have 15 and ASHRAE 15.2 built into these. And so we're going to update our software by adding these shut-off valve kits. The concept of releasable charge and minimum room volume are all going to be added into this. And of course, we're going to have all these components built into our units as well.
got it.
So this is a screenshot from our selection software, and there's a place here where you would input your pipe lengths from your branches out to your indoor units. And what you will do is you'll have the option to add a valve box, and then it will ask you where in this piping you want to put that valve kit. So you'll input that length into the software, and that will be how you will get those added in. And again, you only need these where you need them. You're not going to put these on every single room or zone.
Mm-hmm.
So, oh, and then yeah, when you do select this, it will show up in your tree diagram with the little green box. It's got a V in it to show that you put a valve there. So that's how those will be dropped in. And then we will have a refrigerant checker built in. So this will check the refrigerant and the room volume for you. So after you get
Nice.
all your information input into this, models, pipe lengths, do I have a box, a valve kit or not, room information, you then run this refrigerant checker based on the calculations for ASHRAE 15. And because 15 and 15.2 do have different calculations and requirements, there's a place here where you can select which standard you're applying your system to, which is good. The actual room volume here shown is calculated based on the room area and the height that you entered previously in that room information window. The releasable charge, MREL, is also going to be calculated for you on this
Mm-hmm.
checker, which is good. And then what else is this going to do here? Well, in this example, I guess we can pick this apart here. We've got several zones here. You'll see that these first two indoor units and the third one shows what this calculation is going to be. You'll see that for this third room, it's much higher. And this is simply because there's no release mitigation controls used on this particular zone. So it will actually tell you where you're at depending on valves or not and what you're doing.
Mm-hmm.
So that's pretty handy as well. And then just to touch on installation and service, nothing changes as far as that goes. You still need to do a nitrogen purge when you're brazing pipe. But that's nothing new. You should have been doing that already.
Right.
Shame on you. So
Should be doing that.
yeah, compressors don't like chewing up trash. So strength and leak testing, I guess there'll be some kind of declaration that that's done. And then
Mm-hmm.
charging and recovery, um, all your gauges are going to have to be rated for the new refrigerant. So
Yeah.
people need to get separate equipment for this stuff,
Yep.
and including your pumps. So that's the end of what I've got for
Excellent.
this. I know it's a lot of stuff, but hopefully we've explained it and then also given you some reassurance and tools for doing this in the future.
Yeah. While we're on this slide, and it was great information, and we'll do a real recap here in a second, but we did get asked about compression fittings versus
Mm.
brazing. Any thoughts on that from a general overall VRF standpoint? Do you,
Hard
as a
to
manufacturer, do you bless it, or
we
do you just say it's
we
up to you?
we have a neutral stance on it. What we
Okay.
want you to do is install a system that doesn't leak.
Got
So,
it. Got it.
however you can get that done is fine with us.
Right. So you're not taking, I get it. I totally get it.
Yeah,
So
but we're not saying go do it either. We're
you're
remaining
right.
neutral.
You're
Yeah,
responsible for it. I get it totally.
it does
So,
work. So
right, right. So
mhm,
cool. Okay. So to recap, we had some manufacturing deadlines, 1/1/26. I think that's the most important, probably one of the more important pieces. And then we have a 3-year sell through period. So if you've got this in
mhm.
your warehouse and it's
Not moving.
not moving, try to get it out. But there's not a lot of people with, you know, big commercial VRF systems just sitting around in their warehouse. I wouldn't
Yeah,
think.
we see some people storing up some 410 for a little bit, maybe, but
Yeah,
that's about it.
I was in one of our parts offices and they had pallets of it in there. So, um, yeah. So
Equipment
there's,
or
yeah. So
or
there's
refrigerant.
that. The other takeaway I got, well, the refrigerant concentration limits was a big worry. And I
Mhm,
think the main takeaway of this, and the reason I wanted you here, because I didn't know until you just showed me all this, was how are we addressing the concentration limits in the space? And it looks like it's actually easier to meet than
mhm.
before any type of mitigation or valves were added. So I think the big takeaway for that is it's not going to be a problem to meet that in the spaces. And the other takeaway, like you said, is the programs are going to handle that. So
Yeah,
um,
we think we're in pretty good position to, get this going.
excellent. Well, awesome. Well, thank you so much for your joining us. So, again, if you're watching, thank you for being here. Please scroll down the website. If you're watching this live, you scroll down on the website where we're showing the presentation and you could download your PDH certificate. There's one specific to New York. This one was approved in New York. And then the other one is for all the other states that we have listed there. It's probably approved in more states than we have listed. It's just the ones we know about. So do that. Um, if you're watching this in the future, if you're listening to me in the future and you're on, you know, our YouTube channel or podcast, you can click on the video description or the podcast description and it'll tell you my email address. You can email me and I'll get you the PDH certificate that way. So, yeah. So, anyway, Trey, any last words or
No, thanks for having me on, and I'd be happy to do this or something similar anytime you, need it, so just let us know.
we'll take you up on that. We'll definitely have you back in a few months because I'm sure there'll be some more updates, right?
You got it, yeah.
All right.